Hello everyone, welcome. I'm YouTube's Daniel Huffman, and I appreciate you spending some time with me today. I always wonder if I should start exactly at the specified time, because when I teach classes, there's this trickling in that usually takes place over the course of several minutes after the designated start time. But this is all recorded, so you miss something, that's fine. You can always go back. So welcome. This is the sort of third season, as it were, of this live streaming thing that I'm doing. It's not the most consistent. This is the 11th time I've done this over, since 2019. But I appreciate you kind of sticking around and following me on Twitter to figure out what the exact schedule is. And I don't know exactly what this season is going to involve. I have some ideas, but who knows? It's just sort of based on whatever particular inspiration that strikes me. And as I said at the beginning of when I started doing this in 2019, which feels like lifetimes ago at this point, the reason that I like doing this is partly because it stops me from overly obsessing about the things that I want to talk about. I could, and I'm going to talk about color today. I could spend a little while putting together a video. Just a prepackaged video that goes on YouTube, doesn't have any live content or anything like that. But then probably half an hour video I would spend 10 hours on in terms of like editing and doing multiple takes and cutting things together and getting good visuals. Whereas here I'm doing it live, so I just got to live with whatever it is that I say and do. And I put some prep time into this, but definitely not as much. And the other big difference, of course, is that you're all here, which I appreciate because when I talk about cartography things, most of the time I'm talking about it with a group of people. I'm at a conference or I'm teaching a class or something like that, and it's nice to have some energy coming back to me and hear some questions, hear some feedback, people talking about their experiences. So it's good you're here. Thank you for joining, and please feel free to say hello in the chat or as we move on. Talk about your own thoughts about what I'm saying, or ask questions, or point to resources or things you've done, or whatever. It's nice to have this not just be this one-sided thing, definitely. And see, we're already getting chat already. So, and I should mention, if you're not used to this, I'm like 10 seconds time shifted from you as part of this whole live stream process. So I won't always answer chat right away or see what you're saying, but I see that Rocio is saying hi from Mexico, so it's great to have you here, and perhaps other of you are chiming in from elsewhere around the world. Who knows? It's Friday here in Wisconsin, though. So, as I said, today I'm going to talk about color. And specifically, I'm not going to talk about, how to pick the right color for your design, because that's not something that there's a correct answer to. But what instead I'm going to do is I'm going to talk about sort of systems for organizing and thinking about color, because that was something that was really helpful to me. I spent so much time over the years really struggling with color. And I've talked about this before, both here and in some other formats where I've talked about, how I love working in monochrome. It's a big part of my portfolio. I've got all kinds of, let me actually pull this up here for a second. On my portfolio, for example, there's a lot of different things that I've done that are in grayscale. And the reason I have them up here is partly because it's my favorite way to work. I love not having to think about color where everything's just light or dark, and that's much easier to get your head around. And I've given some NACES talks about it and various things like that. But one of the things that's helped me struggle with colors a little bit less is thinking about them in an organized fashion, because what I used to do, a lot of the time, was there was just a lot of sort of, I need a color, let's just kind of click around randomly until I get something that kind of looks like it goes with this other thing, and maybe that's all right. And maybe I'm curious if any of you have also struggled with this kind of approach where you feel like you're just kind of moving randomly and picking things and just hoping you land on something that works, because that's certainly how I've been, and I'm curious if I'm, if that's rare or common. But that's kind of what I want to talk about, thinking in different color systems, because that's helped me organize the way that I approach colors. And it didn't solve all my problems, but it definitely helped me get through that process a little bit more easily. Hello, Amber. Thanks for joining. And I saw on Twitter that you said something about my voice. I have to look up the thing that you said now because I found it interesting that what is it here? Yes, the warm tone of my voice. It's interesting. I've always thought I just have a sort of vaguely nasally annoying Midwestern accent, which, I mean, I don't particularly mind, but it sounds different in my head, certainly to other people. So I appreciate the compliment. And I also appreciate that you have also been totally random in your color selection. I think that's not uncommon. And what I'm basing a lot of what I'm going to say today on is things that I talk to my students about, where they're often approaching all this from the first time. And so they're more likely to be random about doing things. So what's really helped me is to think about colors in an organized fashion. So what I'm just going to do is pull up some slides here. And I just set these up in my broadcasting software. I've never set up slide images this way. And I'm just going to go through some major systems of organizing color. But first we're going to start with this image here of a color. And, one of the things that I always like to do when I talk to people about color is start by showing them this color and ask them to think about how would you describe this thing to somebody who's not looking at this color, right? How do you communicate that? And you might think of different words for it, and feel free, everybody, to sort of put your descriptions of this color in the chat. Be real curious, but I would personally maybe say it's sort of a salmon pink, and it's also, I see, looks very different on my screen than I'm looking at what's coming across the video encoding, and it looks a little bit less reddish there. So that's always one of the problems of color reproduction, is that different devices show things differently. But it's a real inefficient system to try and think about colors just in terms of names, even if it's kind of evocative and can be useful for inspiration. So over time, people have just come up with these sorts of different systems that maybe you've heard about and you've seen in software. Things like, that's the wrong one. There's the right scene. So if you go into a program like Illustrator, or in QGIS or ArcMap or Photoshop, pretty much whatever you're working with, you're going to see options for things like plugging colors in an RGB, or publish colors in HSB, or in many of them, and not all of them, CMYK. And these are systems of communicating and organizing colors. And a mix of peach and red. Yeah, that's a good thought. Thinking about colors in these sort of combinations of things is something we're going to get into in a minute, but I've started to think more in these ideas that this is a mixture of two different colors. That's been helpful, and we'll get into that when we get into the CMYK, but mix of peach and red, definitely agree with that one. So to start understanding color, let's go back to some basics for a minute and talk about how humans perceive color, because there's a zillion colors out there. I just pulled this slide from gosh, I can't even remember where it came from anymore. This has been hanging around my slide decks for so long. But there are zillions and zillions of colors out there, but they can kind of be broken down into three dimensions that humans perceive, because this is all a sensory system, right? This is your eyes taking in information about the wavelength of light, and we're not going to get into some of the physics of it. It's useful and interesting, but I want to keep this focused here. But your eye is basically taking in information about wavelengths of light and trying to create this thing that you sense. And we can break that thing down into three dimensions of hue, saturation, and brightness. And I'm going to actually skip through to the end of this little segment to start with brightness here, because that's probably the most obvious to almost anybody who's familiar with color rudimentarily. Bright colors are lighter. Low brightness colors are darker, right? This is just sort of if you imagine somebody shining a light, it's how bright is that light? Light to dark colors. This is something that sort of most anybody can easily perceive. And the other dimensions sometimes take a little bit more mental tuning to really start to notice more. So I've just got some examples of like sort of brightness ramps for like a blue here, and sort of a light, sort of a yellowish pink, and a grayscale ramp, and then some dots of different brightnesses going left to right. So that one's pretty straightforward, how bright the color is. Let's now tip on over to hue for a second. This one is basically, where are you along the rainbow? It's sort of what we might call the fundamental color of something, and it's a little bit hard to describe verbally, even though it's something that most of us would understand and know when we see it. And it's going to vary a little bit by our own individual color vision, certainly, and we'll get into a little bit of that later. But, the idea that blue is just somehow characteristically very different than red. It has some different, if you're thinking in terms of paint, it has a different pigment in it. It exists in a different place along the spectrum of light. And that's really what, in the physics terms, it comes down to. It has to do with positions of on the spectrum of electromagnetic wavelengths. But anything that we would sort of attach one of those basic color terms to, yellow, green, purple, blue, those are sort of English words for really basic color terms, that's getting at the idea of hue. Now, if we take this concept of hue, and where are we along the spectrum, and we think about, well, that pigment could be blue or yellow, etc., the saturation is how strong or how pure, or on the flip side, how washed out is that pigment. So I could have, for example, a very strong blue on this top bar along the right, and I realize I'm motioning with my mouse, but you can't see my mouse cursor because of the way I set this up. But that's all right. If you look at the bars along the right, we've got a very strong blue, or green, or red. On the other hand, if that pigment isn't coming through as strongly, that's a lower saturation color, and that's along the left, where things are more washed out. It doesn't mean there's nothing there potentially. What it means is actually that we're kind of going to grayscale. We're going to just light and dark, white, black, and gray. Those are low saturation colors. So an image, for example, that's entirely in black and white has no saturation. There's still variations there in colors, right, between light and dark and in between, but it just doesn't have any particular strength of hue to it. So this one is probably, maybe the hardest, I would guess, get your brain around, because we can identify hues easily. Most of us, are sort of familiar with the rainbow, and brightness and darkness, that's a pretty easy concept. But saturation is maybe takes a little bit more time to think about it. It's really just take that fundamental color you have and how washed out is it. So pastels, like in the left side, those are washed out colors, for example, but they can still be light or dark. And you can still have a blue that doesn't have a lot of the blue pigment in it, but is still a dark version of it. So here, for example, I've just got a map that I made at one point, and I just ran a saturation gradient across it. So it gets less saturated on the left to more saturated on the right. Sort of washed out on the left. So if you've seen these little cubes in a color picker in software, right, you're going to see, you might see how these two things play with each other, brightness and saturation. And again, you decrease saturation, you go more toward gray, change the brightness, gets lighter or darker. But it's all about the purity of the color. So this is something that can take some time to get your head around, but it's really powerful once you start to perceive this way. And it's definitely an acquired perception. It's just something to attune yourself to. Just like, I've talked about in here and on other presentations, thinking about typefaces. I spend time with my students talking about, what does this typeface say to you? Does it feel modern or old-fashioned or, medieval or whatever? And that's kind of a muscle you can work in your brain to eventually get better and faster at that. Same thing with colors. So here, I've spent time thinking about this system, getting used to it, so I can tell on the left the pair of colors vary specifically in saturation. They have the same hue, but they have the same brightness, but one's just a little bit less pure of a color. The greens there, the second from the left, those have the same hue. They're both green, and they have the same saturation. They both have basically the same amount of greenness to them, but one is darker than the other, so they vary in brightness. And the one in the middle, they're similar in saturation. It's not real saturated. It's not real bold blue or red. but there's some there, and it's kind of light in brightness. They share brightness, but they vary in hue in this case because one is blue and one is red. So I definitely encourage you to start thinking in these terms, and the more you do, the easier this is going to get. And that's, sometimes just a matter of going around to something like Illustrator or other software that has these things and going to the HSB color picker and just saying like, well, what happens if I take this color here and change its brightness? All right. Raise that, gets a little brighter, lower the saturation, moving more toward a grayscale. Right, white is a form of gray too, on the black to white ramp, so low brightness, no saturation, and so on. And this is something you really have to do for yourself. But the more you play around with that, the more it lets you kind of organize some of the ways that you work in color. So, for example, if I go back to my slides here, here's just a clip of a map that I made some time ago, and one way you can think about the labels for the water bodies here is that they're the same hue and same saturation. They're just a darker version of that color. It's a way of sort of me helping my colors rhyme, as it were. That I want my water feature labels to relate to the water somehow. So it seems very obvious they go together, and that's sort of something I talk about a lot when I talk about typography, is making sure that the colors of your labels, when possible, kind of connect back to the feature they're labeling. So one way to do that is just to think about, well, how can I just change one dimension of color, keep the others the same? So I could go in and say, well, just change the brightness of the underlying map and keep the hue and the saturation the same, and now that works. Or I could use saturation, for example, to create a highlight. I just quick threw this example together, and I've just taken one part of a base map that I had from the same map that you just saw and desaturated part of it. And now that causes one area to kind of pop out more than the other. Generally saturated things kind of draw our attention a little bit more. Humans are drawn to bright, happy colors, and there's all kinds of studies behind that. But I can desaturate other things that still kind of keeps their hue a little bit. It's not black and white. There's still a little bit of that blue and green color in there, but it's just weaker, and now it's more in the background. I might even consider creating a highlight by also changing the brightness. So actually, let me just mock that up for a second. I'm just going to go for a second to where is my... I'm going to go to my portfolio and just grab a screenshot of something here. Oh, wait, I already had my portfolio open in this window. That's where it went. I didn't... My organization gets a little weird when I'm live streaming because I'm only using part of my desktop and I keep other stuff off screen where you can't hear. But if I wanted to take this map, for example, and I'm not going to open the original files, I'm just going to do a quick screenshot here. I'm going to go into Photoshop and paste that in. I could say, for example, let's make a hue saturation adjustment, and I want to mask it. So I'm going to select an area. This is not really intended to be sort of like technical demo time. It's more about color demo, so I won't get too much into the details of how I did this. Hue saturation layer, and I'm going to say, don't change the hue, but take the area that I'm interested in. Take the areas outside what I'm interested in, just tone down their saturation and tone down their lightness. Now I've kind of created something that pops just by thinking in terms of hue and saturation only. Now I've sort of made a little highlight. So obviously, just weird square dropped on top of this map, so it's not the fanciest thing, but kind of gives you an idea where these two dimensions can play out. And Photoshop, in this case, actually has a little tool called Hue Saturation, which actually lets you adjust the hue, saturation, and lightness, which is very similar to brightness, but not quite, for mathematical reasons that we do not need to get into at all. Yeah, that's kind of an idea of seeing this play out. And this is the kind of thing you could do without thinking about hue, saturation, and brightness. But for me, it was the difference between kind of randomly stumbling around blindly and then versus understanding this system and having an organized plan of what I wanted to do because I knew what brightness is. I knew what saturation is. I know what those look like. And so I know the words to look for in the software to get what I'm trying to do done faster and more easily. So, yeah. Hello, Hans. Welcome. I appreciate you taking time in your evening to join me. And what are we up to now? There's 13 people here. That's not bad. Not bad at all, especially for a Friday. Excellent. So these are kind of the perceptual dimensions of color. They've really changed my practice a lot just to understand them. So definitely worth getting into. Now this is sort of one side of the story because that's a very human-centered way of thinking about color in terms of how our brains work for most people. And there are some people who have different varieties of color perception out there, but for the average human, 90 odd % of the people, this is kind of how it all works. Good afternoon, Dylan. Welcome. You might be one of the only Wisconsin people here today. Probably most other people are tuning in for other time zones. I was trying to pick the times for these things that I think will work for a pretty broad group of people. Like, well, it's 1:20 for me in the afternoon, which means it's getting into the evening in Europe, but it's not crazy, and it's also morning potentially for people in New Zealand, for example, that if one of them wants to get up early, they can join in, although it's Saturday over there, so who knows if anyone wants to wake up early on Saturday morning to tune in. So what I want to move on next to is systems for talking to computers about colors, because this is useful for thinking about colors and how humans work with them. It's the wrong thing. That was the thank you slide. We'll come to that later. I've just got what slide deck? There we go. All right. Yeah. Oh, one other example, related things. Hue. You probably think about hue already, potentially some of you, in terms of visual variables. If you've learned your sort of classical visual variables, people like Jacques Breton, they'll talk about hue as an option for conveying sort of qualitative information. So I did this in this clip of a map here where I was talking about different sort of subsistence harvests of groups of people harvesting fish or birds or vegetation for food. And those are fundamentally different kinds of things. And so I used hue for that because hue tends to be non-orderable. Right? Blue isn't more or less than red, isn't more or less than yellow, and so on. So hue is good for making sort of really hard breaks between features, saying these are fundamentally different kinds of things. And saturation and brightness are also visual variables, and if you've made a choropleth map, you've probably been using color schemes that kind of operate in those ways, right? Where maybe you're going light to dark in your choropleth, you're using the brightness dimension. So we're really already, even if you don't think about it in that way, you're already tuning into the human perceptual dimensions of color in your designs. Now, fortunately, because humans think in these terms, or humans perceive, we don't necessarily think in these terms consciously, but because our brains kind of process information in this hue, saturation, value way that it's presented to us, and we've broken it down into these dimensions, fortunately, people who program computers and create software have created the HSV model, where you can actually use numbers to specify colors and tell a computer to get at something that's kind of along the lines of how humans think. And together, these things, you can kind of think of these colors as I stole this from Wikipedia. You can kind of think of these as a sort of cylinder of all the colors, or almost all the colors, that you could create, where your hue, if you ever heard the term hue angle, it's because you can think of all the hues as being a circle, and then each hue can have a value or a saturation. These are the other two dimensions that build up the sort of cylinder. I'm not really explaining that super well, but it's honestly not super important. The main thing to understand is that if you go into Illustrator or Photoshop or QGIS or whatever, most of them are going to have a system where you can plug in colors using HSV or HSB. B and V are interchangeable. If you've ever seen those two, this always confused me for a long time. The hue saturation value and hue saturation brightness are the same thing. And they're just ways of mathematically translating the way that computers think about color into the way that humans perceive color into these dimensions, because when you move this brightness up and down behind the scenes, it's doing some math to transform that into other color systems that the computer actually understands. So that's the super useful that's the super sort of useful one that most things have. Question coming in from Will. Oh, there's mathematical difference between value and brightness in H. Is there? Oh, I was under the impression that they were the same. I thought there was a difference between HSL and HSB, because there's like something about lightness versus brightness that gets mathematically calculated differently. But my source for this information is Wikipedia and like a few sentences and remembering what I read a little bit ago. So it's entirely possible that I'm wrong about that. Okay, you got confused. I get confused too. I am not a super color expert. I've read more than I actually read part of this giant book one time from the 60s about color theory and then forgot all of it as part of a project I did in a previous career. But I think for a practical design situation, probably we don't need to worry too much about HSL versus HSB, HSV. Just the idea that colors are getting lighter or darker, and they're getting more or less bold, and that pigment is showing through, and you're changing what the pigment is. I think that's really, behind the scenes, it's about the way that things get translated into RGB, which is our next system that we're going to talk about, because that's the way that your computer monitor thinks about these things. So let's talk about that for a second. Advance the slides. So probably a lot of you are familiar, at least tangentially, with the RGB system, because this is how your computer and your phone and most any other sort of digital display that uses light shining in your face, this is how they reproduce color. They have, if you get really close to your monitor, you might see that it's made up of a whole bunch of little tiny red, green, and blue lights. Although nowadays monitors are getting so, like the individual elements in the monitors are getting so tiny, it's hard to see nowadays. In the 90s, I could look at my computer monitor and very obviously tell that there were red, green, and blue lights in there, and now it's a lot more difficult. So if you have these, your computer is basically producing colors by taking these red, green, and blue lights and controlling how bright they are. If you turn off the blue light and keep the red light really bright and the green light kind of on, you might get this brownish color. And if you turn down the red light and turn on the blue light part way and turn on the green, then you might get this sort of darkish blue color. It's also helped by the fact that there's black behind all these in your monitor. So we can reproduce colors through combinations of red, green, and blue lights. And again, we could dive in. I don't want to lose focus too much. We could dive into sort of the physics and physiology of how your cones work in your eye and everything. But suffice it to say, these three colors of lights are generally enough to trick your eye into perceiving almost any other color just through combinations. So I'm sorry, I lost track of thought for a minute because something weird happened off the side of my screen. In any case, so the thing to understand about RGB is that it's a computer-first system. It's designed to talk to hardware. This was a solution for specifying colors, in scales from 0 to 255 that physically told hardware what to do via software. And that's why it exists, and probably why it's very popular among designers who deal with the web. So I actually did a where is it? There it is. I did a little survey that actually started this whole thing. I did a little survey on Twitter a couple of months ago, and I asked people, what color model do people think and design in most often? And RGB was the most common, and I think it's because probably a lot of people are doing things primarily for the web, and it's often the default for a lot of software. It's where it starts, is the RGB model of specifying colors. And that actually inspired me to do this whole talk about colors and do a little live stream about it, because I thought it might be interesting to dive into. But for me, the problem is that it's very unintuitive. It's what a lot of people do because it's what their software expects. And if somebody's visiting your website, it's easy to write your HTML in a way that tells their browser what lights to turn on and off to create the colors you want. But I just don't have a really intuitive grasp of kind of how these numbers translate into what I physically perceive when I'm doing my design. And I'm curious if anybody else does, because I feel like you could acquire it. If I switch this thing over to RGB and I say, how can I make this purple here look more like the, let me just center this a little bit better, look more like this green, I don't know how I would have to drag these sliders intuitively to get where I need to go. It just doesn't make sense to me, and I'd just kind of be guessing. Well, okay, maybe more green. It makes sense to add more green, but oh, it got too bright. Okay, what if I tone down the red? And see, it's very trial and error for me. If I have a sort of color direction that I want to go, RGB doesn't make any sense to me, and I'm curious if some of the people who kind of design it are mostly just doing the hunt and pick version where they're going like, oh, no, this looks good, that looks good, and then finally they end up with the color that they want, and they say, oh, that's 185.0.189. And as a side note, if you've seen hex codes for colors, that's the same as these numbers that run from 0 to 255. It's just another way of specifying it, more of a software-oriented hexadecimal. So the B9 here means 185. 00 means 0. BD means 189, because it's in just a base 16 numbering system where the numbers run 0 through 9, and then A, B, C, D, E, F. So if you're curious about that, you can kind of poke around and look for hexadecimal on the internet. There's some good explanations out there. So that's why RGB is popular, which I think is a little unfortunate for a lot of people who think about color and design, just because it's really not geared toward. It's not designed for people to think about color intuitively and create colors with. It's really more of a software and hardware engineering forward way of specifying color. So it's surprising me that it's still so dominant. And I guess it's dominant because it's easier for creating these systems, but it's not really easy for, we have the technology now to give everybody an HSB interface, so I'm surprised that hasn't caught on more. The third system that's pretty common that you'll see in most interfaces besides HSB and HSL is CMYK. And this is designed for, this is also not a human first system in terms of how we understand and how we process colors in our brain. This is also sort of a hardware and practical first implementation. This one is for print though. So here's another example I stole off Wikipedia. If you are thinking about how to print colors in a book, there's a lot of different systems to it, but by far the most common is to print colors using a combination of 4 inks. So if you've got a color printed book and you stick your face in there really close, you're going to see, or if you use a magnifier, you're going to see that it's printed of a bunch of tiny dots of cyan, magenta, yellow, and black ink. This is by far the most common way of doing it. There are a few other systems that use some other colors, but pretty much this is how we do it. And in fact, actually, behind me here are some plates used at a press for printing a book. And there's 4 of them. You can kind of see the edges of them over here. These are like one of these plates told the printing machine where to put the cyan ink, and the other one said where to put the black ink, and where to put the yellow ink, and where to put the magenta ink, and so on. I've actually got a blog post about this if you're interested in reading more, somewhere on my blog. Go to somethingaboutmaps.com, click on my blog, and you will find out if I poke around here. Oh, it's been a while since I wrote this, and I don't make it real easy to search. You just got to scroll through. Well, it's like 6 posts back. Yeah, the pieces of maps behind me. Look for that. Look for like the pieces of maps behind me and something about maps. Probably come up. And oh, you see, I took a screenshot and I changed my brightness and saturation to highlight the things I was interested in. And I just talk about kind of how they get into, oh, I stole the same image from Wikipedia for this blog post too. How about that? So, I've also talked about this in a previous live stream. I talked about simulating this, kind of faking this digitally, pretending your thing looked like an old printed book. So you get the idea. Most of you are probably pretty familiar with this. So we can also specify colors based on the amount of ink that we want to throw down in an individual area, rather than the amount of light that we want our monitor to shine on somebody's face. We're going to print, we could say, well, I want my water to be made of 15% cyan ink. And maybe the label will be that, a little bit more cyan, plus throw a little black ink in there. So does black do? Black makes things darker. So really by black, this kind of almost ties back into HSB. When you're throwing more black ink into something, you're changing its brightness, because that's what black does. This is far and away the way that I think about color the most. But it is also not as intuitive as working in HSB, I will say. HSB fits these perceptual dimensions of color. CMYK can take a little bit more thinking to get your head around. I come from a print design background, so that's why I think a lot in CMYK terms, because I'm thinking about what is actually going to be done in the production of this book. But even then, if I'm designing something for screen only, I still usually do it in CMYK. The way that it's been helpful for me to think about it is just thinking about mixing ink, mixing paint. Probably most of us have experience at some point, even if it's not in a long time, maybe it was when we were children, mixing paints together. So you've got like, oh, if I take if I, for example, start with some yellow or some blue paint, and I say, let's mix some yellow paint into it, well, then it turns into green. I know that yellow and blue makes green. So I can also think of this as saying, well, I took blue and I made it more yellow, and a more yellow blue is green. That kind of thing. This takes some experience to get used to, but it's sort of how I've started to think about it, and it's the reason I asked a few minutes ago about if anybody was developing this intuitive understanding of RGB, because I don't have that intuitive understanding of RGB, but I feel like with a lot of experience with it, I could start to understand that, altering the blueness level of this up and down will take the color in a certain direction, or if I want to make this thing more purple, how would I do that? In CMYK terms, I know I'm probably going to need to increase the magenta and reduce the yellow to get it to be more purple. In RGB, I don't know, but I imagine I could acquire that. So if you work with that a lot, I'd be curious to know whether it works for you that way. For me here, I'd say I know purple is a combination of red and blue. Got a lot of blue here and a lot of yellow. Don't need yellow and purple though, so let's take the yellow down and increase the magenta. And I can fine tune that, etc. But get the idea. So that's kind of how I think about things. And the more ink I add, the more saturated it becomes. So we can tie this back into the HSB system. More pigment means those hues come through more strongly. So the difference between a pure magenta, that's very saturated. Less magenta, less saturated. I can throw a little black in there too to darken it. I can throw a little black into both of them to darken it. Right, so now I've got ones that are pretty similar saturation. They're the same hue pretty much. There's some mathematical transformations that don't quite work out perfectly, but it's basically the same idea. And the difference is pretty much just in brightness between those two. So those are kind of the three really common models, and I tend to think of them a lot when I use my design, especially for how to relate colors to each other so that I'm not randomly choosing. Because I like to think of colors in systems. That's a really good starting point for design. For example, at one point, somebody needed me to design basically a whole bunch of color swatches for them that were going to be similar. Actually, I think I can pull up here. I've got, do I still have that? Let me just pull it out of my old project archive. I was helping them mock something up for a potential sort of computer gamified interface. I needed to come up with some color swatches that were really similar for these cars here. Yes, they're all kind of variations on a green. I didn't want them to be uniform, but they didn't really need to be super distinct from each other. And I didn't need to show like one of these cars is very different, etc. So instead, all of these are just a starting point where I picked like a hue and a saturation and a value, and then I just tweaked it a little bit here and there. And so I can say in this color, for example, now let's brighten this up a little bit and change the saturation to some number and say, okay, there we go. Well, let's take this, copy it, and change the saturation down by a few points, down by 20 points or something like that. All right, let's take this and lower the brightness, but keep the saturation the same. And let's shift the hue just a little bit. See how those all kind of, they're near each other because I only made slight tweaks to one dimension to get them. So it's really useful for me to think about things in this system to get there. Or likewise, if I wanted to, say, take one of these things and label it, I'd like a slightly darker version for my text. So imagine this thing to the left that I just dragged is going to be the text color. Or actually, I can probably just do... Alright, I want to drop this. Right now it's the same color, but I could say, let's lower the brightness so it kind of still rhymes. Or instead, I could go to the CMYK and say, let's just inject some black into that here. 45% black. So this is kind of what I find helpful. Now a caveat. A couple of caveats here to think about. First off, it's important to understand these systems that we're plugging things in here, these are just various mathematical models of color. They don't cover every color that can possibly exist, but very importantly, it's when I mentioned before this HSB, this is an implementation that actually converts it's actually an implementation, as Craig Williams reminded me, of RGB. It's just a translation between them. Because your computer thinks in RGB. That's just usually what it does most of the time. That's the monitor. I'm looking at Illustrator. It's shining out on me, shining bright lights. So what it's really doing when you're plugging numbers into HSB, it's sending them through formulas and getting an RGB equivalent and telling the computer that. And so it doesn't always correspond exactly with what you might expect sometimes. It's not perfect for the real dimensions of color. Sometimes you might change the saturation and the color actually seems to get a little bit lighter or darker than you were anticipating, just because the model's a little bit imperfect. The other thing to know, and that's really important to understand, is Gamut. So let me go back to my slides here for a second. So maybe you've even seen this term floating around the software. Maybe you know what it means, or maybe you haven't engaged with it before. But these systems for creating color out of lights or creating color out of inks, they can't make every single color that a human can possibly perceive. There are limits. And you can go and you can look around on the concept on Wikipedia, for example, of like, color spaces. Right? A color space is organization of colors, and there's all these different diagrams about what can exist and what RGB can sort of, here's maybe a little bit better one. There's different RGB models, and you can really dive into the weeds of this stuff. Oh, I'm not showing you yep. Sorry, there we go. Now I didn't switch back to my browser here, but you can kind of look at these diagrams and see there's a lot of complexity. In fact, some of these systems even make colors that can't be seen by humans. It's an approximation. For design purposes, though, we usually don't need to worry too much about that in terms of RGB and its potential limitations. What you do need to worry about is the CMYK versus RGB gamut, because CMYK contains fewer colors than RGB. What that means is there are colors that you can create on your computer screen that cannot be printed in CMYK. And so that's why I've got these sort of equivalent versions here. If I take a bright green in RGB on my computer screen and I try and print it, it's going to come out kind of dull. And so that's just a caveat when you're thinking about doing print design. And that's why it's very important to make sure your software is showing you sort of colors that are possible. And if you work in Illustrator, you have that option. So I actually have under File, there's Document Color Mode. And I can work in RGB, for example. And I can say, well, let's work in RGB and make this, very bright green, for example. Notice there's a little flag here. It says out of gamut warning. Click to correct. And showing me, here's the nearest color in a CMYK gamut. But also, instead, if I go switch my document color mode back to CMYK, it makes sure that I'm always confined to the space of colors that can be printed in CMYK. You could still print colors that are outside of that. And if you go to like a commercial press, you can ask for special inks, spot colors they're called, that are not one of those standard 4 ink colors that you can then get a special color that can't be reproduced. And if you own the second volume of the Atlas of Design, you may have seen one of those, because there is a map printed in the second volume that uses a really bright fluorescent yellow that when I was co-editing that volume, and we got the person who created that map asked for that color to be used, and we got the press to add a 5th color just to that page that was this really bright yellow that the author wanted. So that's a really important thing to understand. It's about just to make sure that you're working in the correct gamut, because this throws people off a lot of the time, especially when they're converting from something, when they're trying to print out something that they've designed on screen in RGB. Sometimes they're like, why are the colors so dull? And it has to do with, you can only make certain things out of ink. If I want to make a bright green, for example, on your monitor, I can shine a bright green light in your face. That's great. If I want to make green out of paint, I can mix the cyan and the yellow together. And if you think about mixing paints together and inks together, maybe in your experience you've noticed the more inks you add together, the darker things get. And since you have to mix things together to get green, it means you can't get a very bright green, basically. And there are other printing processes that you have an extra green thrown in to kind of improve that, but for the most part, this is kind of what we're working with. I think that is... Anything else? Oh, yes. The last thing I want to talk about, too, on this sort of topic is perceptual spaces. All these systems are models, right? We specifying numbers for shining lights, specifying numbers for adding inks. All these are about generally, or the HSB is really just RGB in the background. All these are models for describing colors, and it's nice because it allows me to communicate to somebody on the other side of the world exactly what color I want, but they don't always correspond perfectly to what we see, because human color vision is not something that's mathematical. It's not something we can just download a table that says this is exactly how people perceive colors. It's much more, it's fuzzier than that, right? And I was talking about the perceptual dimensions, these kind of vague terms of, well, what is a hue? Saturation makes things more or less pure, etc. And so this causes some problems when we try and mathematically model it. What can happen when we mathematically model a color is that changes in number don't always correspond to changes in perception. So notice, for example, in an RGB system, if you have 10 units of red versus 50 units of red, that's a very difficult to distinguish difference. They look pretty close to each other. The difference between those two colors seems much closer than the difference between 250 red and 210 red. Right? It seems like it's not even though the numbers are even, it's 40 units. The amount that we perceive is not even. Same thing in a CMYK. 10% black and 20% black, usually you can see the difference between those pretty clearly. Difference between 90% black and 100% black, maybe not as clear, even though, once again, it's a difference in 10% in black ink that's being laid down. These are mathematical models, but the amount that you move in this color space, and that's a term that maybe I should go back and talk about for a minute. It's just the idea that, if we're specifying colors using 2 to 3 numbers here, you can imagine kind of plotting it in a 3D space. That's also RGB is you can imagine like a 3D cube of colors. So in a color space, just because you moved a certain amount doesn't always mean that corresponds to the exact same sort of perceptual difference. And this is something artists have known for a long time. So if I'm going to skip over here to, maybe you've seen these Munsell books of color. There was this American artist in the 20th century named Munsell, and he basically painted a whole bunch of chips and then asked people to arrange them based on what they thought, were even visual differences. And he came up with this very It's not mathematical, right? It was very perceptually based, very tied into how humans see things. But he was sort of able to create these sortations of colors based on experience. And if you look at his color system, here's a little 3D model of it. Notice, and it's basically an HSV system. It's got hue as you go around, you get some reds and blues and greens. And as you go from the core to the outside, you change in saturation. And if you go from top to bottom, you change in brightness. But notice it's very uneven. And that's because humans, for example, can see a lot more distinctions in red and pink. On the other hand, if you notice, there's only, if you look toward the back, there's not a lot of yellows or oranges. There's far fewer of them, fewer steps of them, because humans are not as sensitive in that part of the color space. So human sensitivity varies and human perception varies, and that's not accounted for in these models. So that's why just saying like, oh, I'm going to create a map where every color is 10% blacker than the next, that won't necessarily look even. And if you go to like a popular set of colors like the ones at Color Brewer, you can even see that they based theirs on Munsell charts. They based what they created, they looked at the Munsell system, which was very perceptually even. And so on their grayscale scheme, for example, you notice the amount of black ink doesn't go up by the same amount each time to create an even spacing. It goes up by 17%, then 21%, then 20%, then 24% to make that work. And there's room to quibble. Maybe different people's perceptions are a little bit different, but definitely it's not mathematically even. It's usually good enough for a lot of purposes, and I will certainly sometimes, for my own convenience, do mathematically even color spaces, groups of colors, just because it's maybe in the situation I'm designing for, it doesn't matter a huge amount. But that's something to be aware of as far as the what we call the non-perceptuality of these systems. Rocio asks, is there a way to convert Munsell to HSV? There are conversions for Munsell to various other systems. So actually the behind the scenes of Color Brewer, they hold on. Behind the scenes, what powers Color Brewer is these Munsell chips that they converted over into RGB and CMYK, and I'm not sure what they used as their specific source for this, but those have been published. What I would really, really like to see is for Munsell chips to exist in more software, because I'd really like to be able to go in Illustrator and have like a Munsell set of sliders where it'd really just be this HSB, because his system also was hue, saturation, and brightness, but if you were in the reds, there would be more steps of saturation because humans are more sensitive to red. And if you're in the yellows, there's fewer of them. And there's sort of these, it would be broken down into a few even steps. I'd really like to see that, and I wish there were something like that would be implemented, but I'm not aware of it, and I was lamenting about it on, was it on Twitter maybe, or it might have been on the spatial community Slack at one point, wishing that there were that kind of thing. So if anybody sees this and has those kind of skills and wants to code that kind of thing into GIS software and graphic design software, that'd be pretty awesome. If you have a Munsell value, being able to convert it, that was. You're hallucinating the print. Sorry, there's a cat now in my lap. I can't. My computer monitor doesn't turn down very far. But this is one of the cats that I'm boarding for the last few months, and as their ordinary human is undergoing a little housing instability, and they're very friendly. Like to usually step on my keyboard, so at least this time she didn't. If you have a Munsell value, being able to convert it. I know these resources exist, but I don't know where. I don't know where they might exist. But I imagine some Googling will probably take you in that direction, hopefully. And if not, bother Craig Williams at Esri, because he knows a lot about some of this behind the scenes stuff, and when I talk about color, he'll pop out of nowhere and say, well, actually, this or that was done in the conversions for Color Brewer, and we've had some discussions about that. So he might have some links to resources for that kind of thing. A request from Gokul for posting more Blender map tutorials. Maybe at some point. The one that I wrote was definitely, it's the longest thing I ever wrote in my life, and it took forever, and I got to build up the strength to do another one, but I have thought about maybe something relating to sort of putting together like something like this, like a 3D view. It's not the greatest. There are people out there who do a better job, but at least going through the basic steps of these kind of things. So maybe at some point I might instead talk very briefly at a conference about it and save that video and put it out there. But we'll see. There's some, but it's good to know what people want to hear and what people are interested in, and I can kind of use that for inspiration when I kind of get the energy to go live from time to time. So as far as color goes, that's kind of the basics of color systems and why I think they're useful. It really helped me stop struggling as much, and I still struggle with color. It's not. There's still a lot of like hemming and hawing, thinking, oh, do I want this to be more red or more blue? Does this not look good? Does this other one? But this system of organization has helped me quite a bit in making my color searches at least a little less random. And so I hope that's what this kind of thing can do for you as well. It's not going to solve all your problems. Maybe you also might just find it interesting, even if you're never going to design things like, oh, that's what RGB means. That's what CMYK goes to, and how halftoning works. But I think that it's been, hopefully at least helps you kind of sort through things a little bit faster if you're not going to work in monochrome, which is still, in my opinion, one of the easier things to work through, because then you just really have to deal with light and dark. It's real easy. It's great. So yeah, that's kind of what I've got for you for today. And it's always weird that these things always tend to take almost exactly an hour, even though I don't plan them specifically to be that way. So chime in with your questions if you want to keep going, or if there's anything you want to tune that you didn't ask for, you want me to sort of tune my attention to. And I appreciate those of you who've been chiming in the meanwhile. And while you're typing and thinking, I will, as usual, say thank you to everybody out there who supports my efforts in sort of bringing to you random tutorials and live streams and maps of where you can find weird flavors of ice cream and all kinds of stuff like that. I really appreciate it. And if you can't support via Patreon, that's perfectly fine. One way you can support me is just to share around my work, tell more people about the stuff that I do, because that leads to more support down the line. More people that means more people buy prints of the things that I make, or they hire me as a freelancer to do things, or etc. etc. So just sharing the word, that means a lot, and that goes a long way. All right, so questions here. Let's see, how do you relate hue with the theme of the map and build your palette for themes without conventions? Oh yeah, that's. And Brandon's going to try CMYK more. Awesome. I'm a CMYK designer, so I appreciate that a lot. As far as with the theme of the map, what I tend to do, well, one thing that I sometimes get away with is actually happening in one current potential project of mine, is that a client was kind enough to share a branding guideline. I might be making a map for a county in Utah, and they have like colors for their county signage. So I'm like, oh, I could use this in a map. This is great. I don't have to think too hard. And I was using my sort of color system knowledge to think about, okay, well, these three colors all kind of share a similar hue at different saturations and brightnesses. Right, and this one is a very different hue, so that'll pop out. This is also more saturated. It will pop out and draw more attention, so I can put like the major information on top, background information in these kind of less saturated, lighter colors. This is darker but not as saturated, so it'll stand against these two on the left without popping out as much. So I was starting to think in those terms. But otherwise, if there's land and water on my map, often, and I don't know where to go, I'll just usually start with like, well, let's make the water blue. That sounds good. Let's, very conventional. Let's make the land white or yellowish or greenish. And maybe, I don't know, does anybody else have any ways that you start your things out? Because definitely you're welcome to chime in and answer each other's questions, because this is definitely an area that I struggle with. I think that occasionally I've thought about colors that can be calming or threatening. I've done projects where, for example, I have made maps that are intended to, like as teaching pieces specifically, I've made maps. I'm just poking around here looking for where these might have gone. And are intended to be a little bit more, make things seem good or bad. So where are they? So yeah, I made a map. Made a couple of maps that were used by the Leventhal Map Center at the Boston Public Library, and they wanted to show students how maps can propagandize. So I showed the same data set in a couple of different ways. And let me just fit this in here about how, free Wi-Fi and showing census data about places that have access to the internet or not, and the dots are the Wi-Fi service, so you can see what areas are covered or not. And I wanted it to look kind of foreboding, and so I was like, red is kind of a threatening color, so that'll be like maybe seem things bad. Red is kind of alarming, versus if I picked this one here, I showed the same data set and said everything's great, there's plenty of free Wi-Fi. I picked these bright, more saturated, happy, childlike colors, so that seemed to me to be a little bit more relaxing and friendly. But it's a real, like, this is where I get advice from other people. Definitely, this is a weak point for me, but also it's about looking around and seeing, like, what kinds of maps what kind of graphics do we show to children? Those are probably happy, fun things, so those are good color palettes. And just stealing other people's ideas. With COVID maps, variables like death, and there's a tension there, right? You want to show, deaths and cases of COVID, those are not good things. You also don't want to be alarmist, right? You want people to feel like this is serious. You wouldn't want to make a map of COVID cases like with this color scheme I'm showing you here, because that seems grossly inappropriate to make light of it. And so there's a balance between how much do you want to create that tension through darker things and reddish colors, and I think dark backgrounds with these sort of colors popping off of it feels more foreboding, but also you don't want to make people feel too uncomfortable and sad all the time. So, and you want to look potentially, your news organization or government, you want to look professional about it and not like a Hollywood movie. And I think there's just, for me, it's a lot of trial and error. And honestly, what I do nowadays is I steal palettes from my old projects. There's things that I know I did before that I think look kind of good, and something in my next project, I'll just go and open the old file and say, yeah, let's just copy those colors. I don't have to think about it. It's great. So, but it's a good question, and it's an important question, and I have kind of only vague answers to it. Anybody else have any parting thoughts before we sign off? And I know there's a time delay here, so I'm just going to sit here and you can listen to the cat purr in the meanwhile. This is like when I ask my students questions and I just wait a little while. Maybe someone has something, and it's fine if nobody does too. All right, well, and thank you, Rocio, for asking questions and for participating, and for, and thank you to all of you who've said things in chat, and for those of you who've lurked and listened. And if somebody watches this video months later, thanks for being here too. With that, I think I'm going to leave off for now, and wish you all a good day. It's been great having you with me to reconnect a little bit in these COVID times, and I'm sure I'll do this again at some future point. And meanwhile, take care, everyone.